Hey guys, welcome to Brad and Pratt. Let's jump into longest common prefix, one of the most popular questions asked in Trie. So here you can see, which is basically pretty direct. You have to find out the longest common prefix given a list of strings. Now, this is pretty straightforward actually. If you do it the brute force way, you can see the easy tag. So what would the brute force solution be? I would simply just sort the arrays using array sort, so it gets sorted lexicographically, and I'll take the last element, and I'll take the first element, and I'll compare each character both at the same time, and whenever the characters are not same, that is when I end the loop and return the longest common prefix, which is FL. But this is not that efficient, and we're trying to do this the Trie way. And if you do it the brute force way, it will pass because the constraints are pretty low. But today we're here to do this using a Trie. So obviously first off, we need to write our Trie class and our node class. So let's go in and write in our node class. So if you haven't seen my previous videos, I'll attach the link in the description. Please go through them. So yeah, we'll have our array of pointers or object references which point to node itself of size 26, and then we have a boolean flag to tell whether it's the end of the flag or not. Now, I also wrote a function last time, public boolean contains char ch, and we return whether or not the character actually exists in the array, if there's any object ID reference to it. So I'll check whether if it's not null. That's all. Yeah, that's pretty much our node class. Now let's hop in writing the Trie class. Notice I'm using static class, so that I don't need to mention the outer class first and then the inner class. So this is for ease of coding. Class Trie, I'll obviously have the root node, that's all I need, and let's now write a constructor for our Trie. So whenever I instantiate it, root is equal to new node. So we just instantiate, and if you haven't seen my previous video, please do check it out. I've clearly explained how the insert function works and how the Trie data structure looks like. So I'll just simply go ahead and write that down. So public, obviously it's going to be void insert. We're going to insert a string. And obviously we need to start from the root. So I'm going to declare a temporary node variable to start from the root. And now I will traverse through the character key dot to char array. Now what am I doing? I'm checking whether or not it exists in the current node we are at. Right now we're at the root, so I'm going to check if it contains the contains function that we've written here. So I'm going to check if that character exists or not. If it doesn't exist, then at that index create a new node and point there. So I'm going to create a new node and it'll directly store the object ID reference, and then I want to traverse to that node, the new node I have created. So this will store the object ID reference and then we'll go to that node. And once we're done traversing the whole string, the last node is always the end of the word, so we're going to set that to true. If you're not able to understand this, I request you guys to watch my previous videos, the link to which will be in the description below. So yeah, now we have our insert ready, we have everything ready, and now let's go back here and let's instantiate our Trie to new Trie. So now we have a new Trie. Now I want to insert every word. in strs into my Trie. So I'll do trie dot insert the word simply. Now this is well and good. Now all of my words are in the trie. Now how exactly do I find the longest common prefix? So let's jump right into that. Now first, suppose using the same example where I have an array flower and flow and flight. So this is the array I have. Now how does this look when I add it to my trie? Obviously I'll have my root node, and when I add flower first, I'll obviously have, and I'll have the isEnd flag here, which will obviously be false, so I'll just write f here. Now at wherever the location of f exists, or the index, the ASCII value -97, which gives me the index of f, I'll create a new node and I'll point to there. So this will be node f, and then similarly this goes on for L. I'll have an L node. For O, I'll have the O node, and then for, so that's FLO W. So for simplicity's sake, let's just write it character by character. I guess you guys understand how the node structure looks like over here, right? If you understand this, to understand the longest common prefix code, I'll just write it in a simpler way. So we have our array here. Now when I add this, I'll first have f. This is in the root level. This is in the root level. I'll have f followed by L, followed by O, followed by W, followed by E, followed by R. And at this point the flag will be true. For the isEnd flag will be true. Now when I add the next word, f is already there, L is already there, O is already there, W is already there. So the whole word is already there. But when I reach W, I've reached the end of the word for flow. So hence I'll add my isEnd as true. So this will be true, the isEnd boolean flag. Now when I add the next word flight, here's what happens. F, so I have f, I have L, so I'll just simply, since it's already there, I'll just go to f at the root level, then I'll go to L, and then I observe that there is no I. There's an O here, but there's no I. So I'll insert that at node L. So I'll insert node I, and I'll make sure at node L it points to I. And then from here I'll add the rest of the word, which is basically G H T. Now if our trie structure looks like this, how can I get the longest common prefix? Now by looking at this data, we know that F L O W, is that the longest common prefix? No, because after FL I have I here. So the longest common prefix for all the three is FL. So how do I figure this out in my trie data structure? Now let's just say I add in another word. Let's just call it bus. Maybe bus. Now how would this look like? At the root level for B, which will be somewhere here, I'll have a node created, and then I'll have US. So this is how a tree would look like. This is at the root level. So what you see here is at the root level. So this is the root level array. It will contain the object ID reference for node B, and this will contain the object ID reference for node F. Now with this understanding, this is how a trie looks. Now what is the longest common prefix here? The longest common prefix is nothing here, because if you see, there is nothing in common in all of these, because although these three words start with FL, this doesn't. This starts with B. Now if you observe at the root level, I have two object ID references in my array. So this is how my root node would look like. My root node, I'll have my array of 26 pointers here, or object ID references, and somewhere at B and somewhere at F I'll have some number which is the object ID reference to that node B and node F. Now if you observe, the rest all will be null. The rest all are null. Now if you observe, what is the count of the not null? I want you to hear me carefully. I'll ask that again. What is the count of the not null here? It's 2. So I have 2 characters present at the root level. So for the longest common prefix, the main logic is that at every level I should only have one character available in that array. I should only have one character available. Whenever I have something greater than 1, that is when I break my loop and then find the common prefix. So here, since I have 2 in my level, at the root level, I don't have any common prefix. Now if I go back to my previous example, now if you see, at the root level I just have 1. I just have one character present, or one node present. So hence I'll traverse to that node. Now at node F, I have how many? I only have one character, which is L. Then I'll go to L. Now at this node L, how many pointers do I have? If you see, I have 2 pointers. One is pointing to O, one is pointing to I, or in Java that would be an object ID reference. So at this place I end the loop, I break the loop, and then I realize that okay, FL was my common prefix. So that is how I can efficiently get my common prefix, just by knowing how many nodes are there at that level or at that node. So hence, let's jump back to the question, and now we have to modify our trie structure a little bit. Now I need to know the count, right? So at the node level, at each and every node level, I want to know the count. So hence I'll add a count variable. And again, if you guys remember, since this is an instance variable, this would automatically be instantiated to 0, since I didn't write any constructor for node explicitly. Now when do I change this count? Whenever I add a new character. So whenever I add a new character, I want to change my count. I want to increment my count here. Not when I'm traversing. This is the traversal part where you're going from one node to the other. Now if the character doesn't exist, you're adding the character and then incrementing the count at that level to understand how many new nodes have been created at that level. Now if a character already exists, I'll just simply traverse to that node. So then the count plus plus will never happen. So you have to be careful that this count plus plus only happens when you're inserting a new character that hasn't been seen at that node level, right? Now all of this is fine. Now how do I find the common prefix? So now let's write the actual function to find the longest common prefix. So we'll write that under the trie class itself. Let's just call it find. And since we have to return a string, the return type will be string. We're not passing anything. And obviously we're going to start from the root node. So we need this. And we're going to be building the prefix as we move down the trie. So that's why I am declaring and initializing a new string builder. So we have string builder prefix. Now we want to start at the root, and I want to check whether at this moment where I'm standing right now, I'm at the root level. Now if you remember, I said that the count should be equal to 1. So here, if you remember, the count was 1, so it was fine. So we went down. Again, the count at the root level, the count was 1. I only had F, so that was fine, and then traverse to F. Now once I'm at F, I check how many pointers are there or how many object references are there in that array. There's only one that's pointing to L, so I'll go to that. And now when I reach L, I see that there are 2 pointers, which is greater than 1. Which is greater than 1. So 2 is greater than 1, right? So this is when I want to end my loop and then return this. So as we traverse our trie, we are going to build our prefix. So let's go back to that. Now, so hence I'm going to check whether the count is equal to 1. While the count is always equal to 1, I'll keep traversing down. I'll keep traversing down. So, and I'll also check whether that current node is null or not. Like, let's just say we didn't add anything into the root, then the root will completely be null, right? It was never created in the first place. So in that case, we just want to return an empty string. So when we instantiate the prefix builder or the string builder, this will by default be an empty string. This is what we are going to return, the prefix. We're going to build it and we're going to return that. Now, at this level, what I'm going to do is I'm going to traverse the whole array. I'm going to check the whole array. I'm going to check this array you see here at that level or at that node. I'm going to check, since the count is the count is 1, so only when the count is 1 I enter this loop. Now I want to check where exactly is that character or where exactly is that node, to be precise. So if I have F first, where is that F? I need to find it, right? So that's why I'm traversing from 0 till 26, since there are 26 elements in the array, and I'll keep on incrementing it. And now here I want to check if temp.chars of I is not equal to null. If it is not equal to null, then I want you to add this into the prefix. I want you to add this character into the prefix. Now here's the thing, I'm not explicitly storing any character here. This is of type node, and all I have is the index in hand with me. Now how are we changing the character to index? We are doing ch minus a. So if I want the ASCII value back, what will I do? I'll do I plus a. This will give me the ASCII value, but I want the character, not the ASCII value. So this is when I have to typecast it to a char type or character type. Now once this has been added, I'll then want to traverse down the tree. We have to traverse down the tree. Now in insert, how are we traversing? This is how we're traversing. So that I'll write the same thing here, temp.chars of, but to what index? To this index specifically. But if you see, int I is bound to this for loop over here. I can't use it outside. So what will I do? I'll declare another variable. I'll initialize it to -1 first, and whenever I find that it's not null, I'm adding it to my string builder, and then I'm storing this index. And I want to travel to that node now, so hence this line. Okay, now all seems good, but we haven't returned that. So once we're done with this, let's make sure we return our prefix dot toString, changing it into a string. Okay, and let's call it over here. So once we've inserted all the words, let's call our function over here. Now let's run this code. Okay, oops. So let's write return, since this is returning a string anyway, return trie.find. So yeah, it's working. Now there's a slight problem though. Like, let's just say I have a test case where I have AB, and then I'll have ABC, and then I have ABCD. what should this actually return? It should return AB, right? Since that is a common prefix among all the words in this. So let's run our code to see if it's working. We're getting a wrong answer. Our output is coming ABCD and the expected is AB. You might be wondering why. So let's go back to our board here and let's understand why our code is not working for that input. So I have AB, I'll have ABC, and then I have ABCD. Our expected is obviously to return AB, but what are we returning? We are returning ABCD in the current code. Now why is that happening? First, let's draw out the trie first. So we have a root, and then the root is then pointing to A, only A, yeah, and then it'll point to B. Now observe at B, since this is the first word, this is now true. The flag is true. The flag here is false. The flag here is true. Now when I go further down, when I go to the next word, obviously A exists, B exists, so I'm just going to traverse, and then I'll add C, and I've reached the end of the word here. I've reached the end of the word, so now I'll have to mark it as true. Its flag as true. Now the next word. Now the next word, I'll first take A exists, so from the root I'll travel to A, and then I have B already exists, so from A I'll travel to B. Now then C already exists, so from B I'll travel to C. Now when I'm at D, since D doesn't exist, I'll add it. I'll add D, and now I'll make my flag as true since we've reached the end of the word. In our code, what are we doing? Let's go back to that once. In our code, we are checking whether our counter is 1. So let me just zoom into it a bit. Yeah, we're just checking whether while our count is equal to 1, that's what we want, right? Because we don't want 2 characters or more than 1 characters or nodes at that level. So we're always checking that this condition applies, and then only we get into this. And this is pretty much straightforward of how we're traversing and then returning. So how is this code working here? Let's run through it once. So I'm at the root. Now I see that there's only one. The count is 1 since there's only one pointer that's pointing to A, or one object array reference that's pointing to A. So then I'll traverse there. Now at this level, at this node, again the count is 1 since there's only B, so I'll traverse there. Now actually our longest common prefix is supposed to be AB, but now what is happening is once we reach B, we are then again checking whether the count is 1 at this place or not. Yes, the count is 1 since it's pointing to C, so then it's going to C, and then it's going to and then similarly at C, what is happening? Again it's checking the count whether it's 1 or not. Yes, the count is 1 since it only has one pointer to D, and then it'll go to D, and that is how the prefix is building up to be A, B, C, and then D. So we're getting an output of A, B, C. Now basically if you observe, AB itself is a word that has been inputted. Now if my input was, let's say, ABC, ABCD, ABCDE, what should the longest common prefix be? Obviously ABC. Now if you observe here also in this example, ABC itself is a word. So what does this indicate? We are not checking the flag. We are not checking our Boolean flag. So this is very important. So now how do I change my code? I have to make sure that the end of the flag is false. Yes, you heard me right. I have to make sure the end of the flag is false. See here, I've reached here, the end of the flag is false. The count is 1 since there's only one pointer, so I'll go here. Now once I reach node B, first I'll check Does it have count 1? Yes, the count is 1 since there's only one pointer. But my flag is true. That means this is a complete word that has been inserted into the list or our string array. So hence this will automatically be my common prefix. So I'll break the loop over here. So I'll break the loop whenever my flag is false. So let's go back and change our while condition. Let's change our while condition to add while our temp.isEnd is equal to false. So whenever it's false, please continue doing this process. Please continue doing this process. So just by adding this condition, now let's run our code again. Let's run our code again and see my test case that I given, and it passed. So now let's submit it. And there we go, guys. That's how we can use trie and find out the longest common prefix. And if you're wondering what the time complexity will be, well, it's obviously O of n, because at a worst case, let's just say I have apple. So I have a list of apples like that. What will the longest common prefix be? Apple. And how will that be stored? Obviously like this, right? So what is my worst case scenario? What is my worst case scenario that I traverse the list? Oh, sorry, the trie. So I'm traversing the whole trie here. I'm traversing the whole trie. So that's why the complexity here is O of n. And that's why using trie here is efficient. Thank you for watching. In the next video, we'll be seeing more deeper applications of trie, like search suggestions, dictionaries, and there's a lot more problems lined up. And we'll also see how the trie can also be used to store numbers. Thank you for watching.